So after we read the question, we came up with this equation. V is the volume, KT is the constant temperature, and P is the pressure. So then we plugged in the numbers and we multiplied both sides by 0.926, and then here we got the answer 3.2 after we multiplied these two. And then K times 302, and we divided both sides by 302 to get the K by itself, and that was the final answer.
After we found the K, which is 0.0106, we need to find the volume of the pressure at 1.452. To find the volume, we need to multiply 0.0106, which is the K, multiplied by 302, which is the temperature, divided by the pressure, which is 1.452. The answer will be 2.2 liter.
Question 52, Charles' Law. In this question, it says that the volume of an enclosed gas at a constant pressure varies directly as the absolute temperature. So volume, which stands for V, equals pressure. And now, since they said in the question varies directly as the absolute temperature, we're going to be multiplying by the absolute temperature, which is represented by the letter T. When we look at the equation now, we see that we lack a constant, and since we know from the question that it's a power function, we need a constant. So we're going to add a variable k to the function. P in the question is said to be constant, but that doesn't mean that it's the constant of the equation. It's just the constant of the scenario. In the question, they gave us the numbers for B, P, and T, but we lacked the constant, which is the most important, K. So now we're going to use these numbers to find the value of K, so we can solve the next question, or the actual question that they asked us to find is volume, where they only give us pressure and the temperature. So now that we have our equation set and we have the values for the volume and the pressure and the temperature, the only thing that's left out is K, and it's the thing that we need to solve the question. Now we're going to do the math. Finally, we find the value of K, which is the constant. And now we can just write our equation and solve the other part of the question.
To find the volume, we will multiply 0.0124 and 0.926 atm and 338, which is the temperature, which will equal to 3.88 liter.
Windmill power. The power P in watts produced by a windmill is proportional to the cube of the wind speed V in mph. If a wind of 10 mph generates 15 watts of power, how much power is generated by winds of 20, 40, and 80 mph? Make a table and explain the pattern. So first of all, I need to write the power function. Power P is proportional to the cube of the wind speed V. So P is equal to K, which is the constant, V cubed. From this scenario right here, I can get the value of K, which is the constant, by writing 15 is equal to K times 10 to the power of 3. Divided by 10 to the power of 3, K is equal to 0.015. Now, since I've got the constant, I can plug it in with the other inputs, which are 20, 40, and 80, to get the power of each one of them. P is equal to 0.015 times 20 to the power of 3, which is equal to 120 watts. Then P is equal to 0.015 times 40 to the power of 3, which is equal to 960 watts. Finally, P is equal to 0.015 times 80 to the power of 3, which is equal to 7680 watts. Now I should write a table. So we have x and y values. X is the input and y is the output. For 10, we've got 15. For 20, we've got 120. For 40, we've got 960. And for 80, we've got 7680.